So before we start, let me just hide all of these control objects here. They're just NURBS curves that are used to control the actual control rig and to give you something to select easily. They're tagged as controllers, which you can do in Maya. When you tag an object as controller, you actually tell Maya that it's a special object. It is just in the scene to control other objects. You can also define a custom hierarchy between controllers so that you can pick walk. So use your keyboard to select up or down the hierarchy, even though those controllers might actually not be really parented to each other. So there are a lot of advantages to using actual control objects and tagging them as controllers. We don't need to see them right now, so I'm just gonna hide them. And taking a look at the mesh, you can see that this is a pretty standard quad only, or in this case almost quad only, subdivision surface mesh. Today there's really no reason not to use any subdivision surfaces. It's pretty much standard throughout the industry. You would probably use classic polymodeling without a subdivision surface on something like a projection mesh, which is just used in a matte painting or in the environment department to project a texture onto. Everything else can just be used, created as a subdivision surface, really. As I said, this is largely quad only. There are very, very few tries, so maybe 8 on the whole model or something like that, and most of them hidden in very, very small areas. There's one try, which is pretty obvious, which is here. I could have let this loop run through the whole geometry, but I would have had to reroute some of them down here. I didn't want to do that and spend any time on that. So since this is a planar surface and this is hard surface mesh, it really doesn't bother me that much. But the general rule still is to use subdivision surfaces. On a character or any kind of thing that deforms, you would never put a triangle even there because it might deform and the triangle might pinch. I knew this mesh would never be deformed, so I decided to just go with it. As a rule, never put in any triangles. They're sometimes pretty handy if they're small to terminate a loop in a very, very non-offending area, so somewhere where you don't see anything. But it depends on your pipeline, so it might be that you're actually not allowed any triangles, or even worse, an n-gon. So check with that. You would never put one on something like the curved surface here of the hood of the engine. It will pinch the surface. It will create a kind of deformation on the surface. So the general rule is do it quad only. It actually requires a bit of experience to know at which places you can actually get away with a triangle. 99% of all the other surfaces are quad only, which is fine. As I said, on a hard surface model, you can keep a triangle if it really doesn't bother you. If you're unsure on how to approach things, keep it quad only. You're always on the safe side. As I said, you need to think about whether you can get away with the triangle on a certain part. It's easier to just... and there's always a way to reroute a loop and to keep it quad only. It might be tedious work, but it's actually worth it. Unless it's on a planar surface, as I said. The reason this is a subdivision surface is, of course, that you can just move far away or close in your renderer of your choice. And if you're using adaptive subdivision, it will always remain smooth. If you're using fixed subdivisions, you can decide per shot how many divisions to actually apply to your surface. In this case here, if I just expand the P51D asset, there's this master group and there's this hierarchy, which basically just holds all of the geometry. If I just press 1 on the keyboard, which in Maya turns off subdivision surface on the mesh, you can see that this mesh is actually detailed enough that it actually works as a level 0 cage from a distance like this. So depending on the shot, I might not need to subdivide this mesh any further anyway. If I move closer, I will use subdivision surfaces. Depending on the pipeline, I might select all these surfaces. And for example, if I'm rendering with Arnold, I might just enable the Cat Clark subdivision on the mesh shape to just do render time subdivisions. In this case, this is not a poly heavy monster, so I can actually use subdivision in the viewport. So I'd like to do that because I'd like to see a smooth preview of iMesh. So I'm going to just select everything, and I'm going to press 3 on the keyboard to turn subdivision surface back on for everything in the hierarchy. And as we can see, our mesh is subdivided again. One thing that is important if you turn off the subdivision on your mesh, there might be cases where some of the interior surfaces might be protruding through the surface at level 0 if it's not subdivided. If you want to use the mesh as your basically non-subdivided base mesh for distance shot, you should be very careful about that. It happens very fast. If you're modeling and you're always looking at a subdivided surface, that you might not see that some of the surfaces are protruding through. So it might be that if I just try to produce that error, if something like this, like the panel of the cockpit sticks through this mesh, if I subdivide it, I actually don't notice. It's hidden. If you keep it that way and you're not subdividing anything, put it back there, you might see that in a distance shot. So be careful about that and triple check that you don't see anything on the mesh that you don't want to see at level 0 if you want to use level 0. As I said, this is meant as an object. It could always be subdivided. So even the smallest parts, even the interior of the cockpit is created as a subdivision surface. You might want to think that it would be easier to just keep that as low poly, non-subdividable surface, because a lot of it might be obstructed by the pilot anyway. In fact, you might not, depending on the usage of your asset, you might not even model that much of the cockpit. I did it because this plane kind of feels unfinished if there's not a full cockpit available within the mesh. And even on distant shot like this, you actually notice the detail. But you might be willing to think, well, I can just get away with a few polygons here and there, just do it low poly. Chances are pretty high that somebody else is going to render this model, and you actually have to communicate with them, in this case, which parts to subdivide and which parts to not subdivide. So it's pretty easy and it's pretty straightforward to just subdivide anything. If you have to give someone a complete list on which shapes to subdivide, not to subdivide, etc., things get complicated. So I'd say it's not a rule, but it's generally advisable. If you start with subdivision surfaces, stick with subdivision surfaces. So usually it's easier to model as a subdivision surface anyway. It might be hard if you're just starting out, but usually it gets easier after some time. And really for these kinds of shapes within the cockpit, or maybe within the gear well area or something like that, it really doesn't make much difference. And if you're worried about polygons, they are relevant for a game. They are relevant for any kind of other production as well. But really, whether you're subdividing these shapes or not, you can always control how much subdivision gets applied. It really doesn't matter that much if you're rendering on your CPU anyway, and most productions still do. If you're rendering on a GPU, it probably doesn't make that much of a difference anyway as well. So yeah, basically the advice is stick to one kind of surface. And since there's really no other way, except, for example, NURBS modeling, which we can't use on any kind of production, film production or virtual reality production, or a game or something like that. So if you can't use a NURBS surface, there's really no other efficient way to model a curved shape like a plane. So yeah, you're basically stuck with subdivision surfaces, and it actually makes sense to use them from a rendering perspective, because your model will remain smooth in all distances. Just keep it easy, make everything subdividable. It will just make pipelining much easier. If for certain reasons other kinds of variations of this model should be needed, for example, a destruction mesh, which is strictly quad only, or which might be actually divided in triangles but is watertight or something like that. Those meshes will be done separately anyway after the main asset is finished or after the hero shot asset is finished. Yeah, just keep sure that everything is inside your main asset, your hero asset, is just modeled to the highest standard that you can do it. So it makes stuff just a lot easier. Another thing that you might have noticed is that when I select these panels, and let me just quickly turn on subdivision for everything again, and we'll just let Maya think about it for a minute, because these are a lot of surfaces with a lot of polys. Not that much, and it's actually pretty easy on the hardware, but it still takes some time to subdivide all of them. It's fast after that, and of course that's real-time toggle on any single surface or even a lot of them. What really is bogging down the performance is all those objects in the cockpit. A lot of them are combined into single shapes, even though they have different shaders assigned. You would normally not necessarily do that. Normally for the shading department, it's much easier if everything that gets a different material is a different shape, but really those things are so small, and your hierarchy will get long if you don't combine some things. So since you're assigning dummy shaders during modeling, probably you can live with that. Normally I'd never combine things that are different materials. Another thing I would normally combine but didn't do in this case are all those individual panels. You might have already noticed that I can actually select every single hull panel right here, and they actually all well, most of them. Those two actually have a different material assigned, but all of the other hull panels here share a material, which is basically just fuselage material, which is a mixed shader that's mixing between a metallic material and a painted material. In this case, I didn't combine the panels to a single mesh with multiple shapes because I wanted to vary some shader properties, and I'm going to take a look at the shader later. But I basically wanted to use the object ID to change some parameters, so this was just convenient, keeping them separately. Normally, you would combine these panels to a single shape. If I expand just a part of the hierarchy here, and we will take a look at this in just a moment as well, there's a lot of objects here, and there's this general rule for any kind of 3D software. They all deal with a lot of polys very well nowadays. But a lot of polys in a lot of different objects will box things down extremely. So if you have like 100,000 objects or even 1,000 in a scene, and they all are pretty much high poly, or even mid poly, or sometimes even low poly if it's really 100,000 objects, things will get slow in your software. So those poly counts might not be a problem if they're all contained in a single object, or maybe 10 of them or something like that. So usually you would like to keep the number of objects low, especially if they don't need to be separated because they are articulating parts, moving parts, or anything like that. But in this case, as I said, there are shading purposes why I kept them separate. So in this case, I kept them separate. As I said, I would normally combine them. But taking a look at the panels, while modeling, you'd usually, so of course the whole fuselage of the plane was one single shape at the very beginning. So since it's a continuous curvature over the whole surface, you basically start your level 0 cage, which is much less refined than this the current detailing of the shape as a single object. And at a certain point, you'd start to actually break the surface up into panels, because if you think about these, this plane is created from different parts in the real world, so you tend to split objects in 3D into those parts. If this was a low poly model that's maybe just meant to be seen from a distance like that or something like this, you probably wouldn't do that. You might just use a bump map, maybe a displacement map if actually it's actually needed. Normally, you just use a bump. In a game, you use a normal map to put in these kind of panel lines that you can see here. But as I said, those are different parts. So you will split them out at a certain point, and there's actually a few things to think about when paneling an object. So you want your surface to remain smooth, its curvature, even though it's broken up into panel lines. So you have to be very careful about your geometry flow to actually be able to cut this surface up into different parts. So you have to make sure that on those connection points, the curvature actually continues and just doesn't suddenly makes a jump or a sharp turn or something like that. Which is why you usually work on a highly subdivided mesh. So this is not exactly many polygons, but the general shape of the plane, of course, wasn't built on this level of detail, so there wasn't that much division. I subdivided the plane at a certain point where I was sure that I wouldn't be needing to change the general shape of it, which is why it's very, very important to study your references very, very carefully, and while modeling to even check the curvature of everything with reference photos. So there's only so much that a blueprint tells you, and of course for a famous plane like a P-51D Mustang, or really any World War II warbirds or cars or something like that, there's blueprints available on the internet anywhere. There's blueprints that you can get if you really need a highly detailed blueprint for a project where really every single detail counts and you get really close to an object. There's always a way you can obtain an actually official blueprint. If it's a commercial project or an educational project, there's usually ways if it's really needed. Otherwise, blueprints from the internet are just working just fine. But they don't tell you much about the curvature of the surface, because you can't see that in blueprint. So you've got your standard side view, top view, etc., etc. So how the surface flows between these very discernible points or lines in the blueprint, you can only find out by studying photos. So before cutting up your plane or any mesh really, or before building your car, you would make sure to have enough references to actually understand how the surface flows. Because if I divided my model this much and I need to change or make a very intense change to the general shape of the object, I probably can't, or I have to think about some tricks. So I certainly don't want to get in here, select an edge loop and just move it about. If I do that with a lot of edge loops on the shape, it's going to destroy my curvature. It's going to totally destroy the shape. If I really need to change something or correct something, I might select a few panels and I might just deform them, just use a lattice to nudge them into a more correct shape. But even that you don't want to do. So before you're actually cutting up your shape into smaller pieces and add the detail, triple check that your mesh is actually corresponding to the actual real world object. You're just gonna make your life much, much easier. There's of course not always references available for everything, so you've kind of like take your chances and make your best bet on what some things might look like in reality. But coming back to the actual panels here, there's a lot of ways you can create panels for a mesh, but there is really only pretty much one standard way, at least in the film industry, and I usually recommend anyone really to use the method because it makes your life so much easier and it has a few advantages. So if I take a look at this mesh, and I turn off the subdivision. I didn't do something that I would normally do on this mesh, and I would always do that if I was going to render just a low poly level 1 cage. But this gives me the opportunity to actually demonstrate why this particular method of creating panels is actually that versatile and that pretty much exclusively used throughout very different branches of the CG industry. And that is the reason that I can just select everything here, and now I do have hard edges on my normals, but I can select all those panels. They're not subdivided at the moment, it's just my current level 0 cage. And I'm just going to go to mesh display, and I'm softening the edge. And what you will see is if I move to the distance, that actually looks pretty freaking much like it is a subdivided surface. So of course, if I take a close look, I can see there's actually segmentation around here, but I don't care for that from this distance. But what I do get is the actual look that I have two panels. They're actually they do have a bevel on their edge. And if I take a really close look on the thing, and I probably should make the normals hard again, they're actually touching. There's no space between these panels whatsoever. They've been cut up from the same piece of geometry. Loops have been added. They're still touching. They're two separate objects, like this. But they're still touching. Because I usually don't want to have some big holes between my panels in the mesh because I can see through them. But I can just subdivide them or make the normals soft, and I do get the impression of panel lines. So now if I go in here, select all these panels again, yeah, that's all. I subdivide them. Of course, the curvature is changing because I'm getting rid of the segmentation up here. But the look along the panel lines pretty much stays the same. So just to expand on that a little bit further, because this is really important for any kind of object that's maybe welded together from different panels or something like that, or even car, where the panel lines are really tiny. Let me just fire up a second Maya instance here. So I'm on macOS right now at home, which really doesn't want me to run a second Maya instance, but you can still do it. So I'm just gonna go open and put it in there. We're of course used to running multiple instances of Maya on Windows all the time. There's usually nothing that breaks. There could be, but well, for quickly just testing something out or for loading a file that somebody sent you or something like that, you really don't want to close your current Maya session because Maya takes forever to load with all its plugins. Let me just quickly demonstrate in a second Maya instance. So I'm just going to create a cylinder here, and maybe going to put it on its side, maybe just throw it in there and get rid of the caps, and most of the surface is really I'm gonna delete everything here, gone. So let's say this is part of my mesh, and maybe I'm just gonna add a second dimension of curvature here really quickly. Let's just go in and move all those surfaces. Let's say that's my shape, and I have to cut it up into panel lines, maybe somewhere here. If I do this right now and just cut this panel here in the middle, I'm probably going to get a problem with the curvature because I'm changing it drastically. There's only two loops right here, and I can do it. I just have to shift around the edge loops actually. Usually it makes a lot of sense to just simply work on the one subdivided mesh. So if I go mesh smooth and just subdivide it even further, I've got a few more polys to work here. Don't like that much divisions in this direction, so just gonna kill a few loops here, and better gonna do that with the delete edge tool so I can get rid of the vertices as well at the same time. So let's say that that's the surface that you want to cut up into panels. So you're gonna get in here and you're actually could cut some new loops to create the panels. Usually you just select everything that belongs to a panel. Let's say this is my panel, and I'm gonna just extract the faces, and this one's a separate panel as well, so I'm gonna extract this one. So I'm gonna delete history here because we really don't need that, and really don't need them to be in separate groups. So if these are my 3 panels, the very first thing I'd do is just extrude all these edges down. So let's choose a small number here, so it's minus 0.1. Should be the same for all the other faces. So I'm going to select my second panel, use all the edges, extrude it, and it was minus 0.1, which basically makes the panel exactly as thick as the other one. And we're gonna do that with this one as well. So extrude, I'm gonna go minus 0.1. Could have done them at the same time, but anyway, it's done. So if I subdivide these shapes, it's not gonna work. Of course, there's pretty smooth areas right here, and everything gets moved. So I've got big holes in between my panels. A lot of people tend to, if I just isolate this part, a lot of people tend to want to select all these edges around here and just come in here and just go, I'm gonna bevel them, and I'm probably gonna give them 2 segments maybe, or something like that. Well, it looks okay unsubdivided. I didn't change anything about the fact that this curve is changing, and I actually introduced way too much geometry. And what I also did is, let me just bevel it again quickly. What I also did is I totally destroyed my ability to use the normals for actually shading this part. So if I go in here and create soft normals for the whole thing, and I'm looking at it from the right angle, I will see that my normals are pretty weird right around the edges, and actually the normal is changing within this polygon to accommodate this already curved edge, which is not planar with the rest of the surface anymore. So basically that's just not the way you'd go about this. Do edge loops. Cut along your edges. Done. Well, actually not done, but that's the general idea of it. So if I come in here, soften the normals, it's gonna look pretty much okay from a distance. There's one thing I didn't do. If you really want to keep the curvature in this part, and you don't want this edge to actually move this far into the shape, add holding edges. So what it means is basically you just need another loop inset into your hull panel, so that you have basically 2 loops on the surface that you want to keep the same. And you will see that this edge, which is actually, well, this is the holding edge. This is just kind of like a control edge. This edge holds its position. This is the way to go about paneling. If I unhide my other objects here, and I'm just quickly gonna do the very same with this panel. This panel, I'm not gonna do the additional edges right now. I'm coming in here and I'll do the same with this panel. Subdivide all of them. Looks pretty nice. So I introduced a little problem right here. So if I wanted to keep the curvature in this place and I don't want the surface to pinch up here, you do have to correct your shape. So if I select all the vertices here, you have to try to keep the curvature consistent. So maybe you have to nudge a few things here and there. It's a bit of work, but it's usually worth it. What's really important here is the fact that from any angle, there's no hole between these surfaces. There can be a very, 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 very little hole right there, but you'd never be able to see through that. So from a distance, that actually looks like a good paneling. And as I said, the advantage is that if I just use softed normals on the shape, it will look the same. So that's pretty much, if you're using subdivision surface modeling anyway, that's pretty much the way to go to panel your surface. And you will always get consistent curvature by just moving a few vertices into position, or by changing the edge flows slightly on a curved surface. You have to be careful how divided your initial mesh is. So if your initial mesh is maybe 8 polygons, you probably won't be able to cut some panel lines in there. If it's sufficiently subdivided, you probably can. As I said, those additional holding edges, you can add them. You should add them normally if the surface is planar. If it's curved, it's not actually needed. There are some kind of panels that are actually bulging outward. On these kinds of panel, and there are a lot of panels on the P51 that are actually kind of bulgy. You don't have to add the additional edge right here. So you can just live with the surface as it is. The curvature right here, basically inward to the actual line between the panels, will be larger. So it might actually not look good. If you're introducing too much curvature by just using one edge, add the second edge all around the surface, and you're basically good to go, and you're done. So just a little detour to explain how I actually modeled the panels on the P51. You will see that in the modeling time-lapse as well. And that's pretty much the last thing I wanted to talk about topology-wise. And as a next step, let me just close this Maya instance here. Take a quick look at the hierarchy of our P51 Mustang and how I decided to group objects in this case. This will usually vary. Shops or any kind of production really will have the naming conventions and rules about that. But there are some general ideas that I want to talk through that usually make life easier. Yeah, let's take a look at that.